Today we continue with nonlinear functions. We are classifying tables and graph. I apologize for not preparing you all for today's video lesson. A couple of notes here. You are expected to pause the presentation as you go through so you can record the notes. I will continue talking throughout the presentation, so please pause as needed. Also, I am recording this presentation from home. Therefore, I don't have a smartboard which to write on. So I'll be using the pen tool to draw, and my awful handwriting will be even worse through this. So please do your best to follow what I'm writing. Any questions that come up you may have during the lesson, I am not there to answer them, obviously. Write them down, and when I return to class on Friday, I will answer them for you. We begin by looking at some graphs, and we've seen these shapes before, and we're going to place them into categories based on how they look. Now, I'm just going to move things around and get them together, no order in particular, but to me, the easiest ones to look at are linear graphs, which are the most common. So I'm going to place all the linear graphs I see in this far left column. Next, I see a graph like this. We know the shape as a parabola. So I'll get some things out of the way here. And we've got our two parabolas in this column. Next, we have our exponential graphs. That, again, we saw back in Unit 2. So I'm going to move them here. And finally, we have our absolute value graphs. Remember, like a big V or a check mark based on how much space we have. And there we go. We look at our four columns, and all the graphs in them are common. So let's go ahead and identify or name the graphs as they appear. This first graph we here on the left, that is an exponential graph. We know that because our lines will never hit where x equals 0. So I'm going to switch this pen tool here and circle exponential. Hopefully it comes out looking okay. And there we go. Not too bad. Our next graph is a parabola. It's kind of wide, but it is a parabola. Parabolas represent quadratic graphs. So I'm going to go ahead and circle that. Okay. And finally, well, not finally, but in this view, finally, we have a straight line. So we know that's linear. Let me go ahead and circle this, and amazingly, my handwriting seems to be better doing it this way than if I was actually there. I'm going to slide. Moving down, we see a parabola again. So we've got a quadratic. So let's fill our points in. When x is -2, y is -5. When x is 0, y is 1. When x is 2, y is 3. When x is 4, y is 1. And when x is 6, 1, 2, 3, 4, 5, 6, y is -5. So again, we have a quadratic here. I'm going to abbreviate it. What I want you to do is take a look at the rate of change in each table. Remember, change in y over change in x. Take a look and come up with the rate of change. So looking at our first table, the rate of change, well here, as y goes down by 3, our x is going up by 1. As y goes down by 1, x goes up by 1. And as y goes, now we're going up, y is up by 1. Our x is 1. And as y goes up by 3 or increases by 3, our x, again, is going up by 1. So our rates of change, -3, -1, 1, and 3. This is not a constant rate of change, but the rate of change itself changes each time. It increases by 2. So the rate of change increases by 2. So if you haven't already, go ahead and figure out the rate of change for the table at the bottom. We have the same thing happening here, except now the rate of change is increasing by 2. Or excuse me, the rate of change and this one decreases by 2. I apologize. So what we can conclude here, the tables of quadratic functions, we can say is that the rate of change, make sure you get this down for our conclusion, the rate of change changes, there's the bad writing, changes at a constant rate. Finish writing this here. There we go. Now, we know about these. We have straight lines on our graphs. These represent linear relationships. So I'm going to save the time of going through this slide. You should fill out the missing parts on your own. But I'm going to skip right down to our conclusion about linear functions. And what we can say is that the rate of change is constant. And we've seen that, I believe, in all 3 of our previous units, definitely 2 of them. But the rate of change is constant. Okay, we now have an absolute value function that we're looking at. I'm just going to go ahead and abbreviate it to AV. And we're going to fill in our table here. So when x is -4, y is 4. When x is -3, y is 2. When x is -2, y is 0. When x is -1, y is 2. And when x is 0, y equals 4. So if we notice the rate of change here, we're going down by 2, down by 2, and then up by 2, up by 2. So what we see happening here, our rate of change is constant until we hit that bottom point. And then it becomes constant going the other direction, or the opposite of the previous rate of change. We have an absolute value function again here. When x is -3, y is 0. When x is -1, y is 1. When x is 1, y is 2. When x is 3, y is 1. When x is 5, y equals 0. So we notice here we're going up by 1, up by 2. Rate of change, 1/2. Up by 1, up by 2, 1/2. Now we hit our reverse point. We go down by 1, up by 2, so we're at negative 1/2. And we're still going down by 1, still going up by 2. We're still at negative 1/2. So the way that I'm going to word this, I'm going to say in an absolute value function, we see that the rate of change is constant on the left side of the graph. Then it changes to the opposite. Rate of change is constant on left, and then it changes to the opposite on the right. And honestly, the longest part of this, guys, is me writing this down. If you already got that part copied, feel free to skip ahead to the next slide. But I'm going to still finish writing this. It's more a personal challenge to me to make this look somewhat readable. Changes to the opposite. I'm going to abbreviate it. On the right. Our last type, we have exponential graphs. I'm going to abbreviate this. And we're going to fill in the points here on our table. So when x is 0, y is 1. When x is 1, y is 2. When x is 2, y is 4. When x is 3, y is 8. Rate of change, we're going up by 1 here. Then we're going up by 2. And we're going up by 4. What do you guys see going on here with our rates of change? Think to yourselves. Let's check the other table on this page. We're going to fill this table in again. So we have when x is 0, y is 2. When x is 1, y is 1. When x is 2, y is negative 1. When x is 3, y is negative 5. Check this rate of change out. So here, we're going down by 1. And here, we're going down by 2. And then here, we're going down by 4. So the tables of exponential functions, we will say our rate of change multiplies at a constant rate. Because if you notice on the table that we can see right now on the screen, we were times negative 1, then times negative 2. And we'll go to the one up top in a second. But multiplies, uh-oh, I don't know how that happened. We're going to leave it there. Multiplies at a constant rate. All right, we go back up here. If we look at this table, we're going times 1, times 2, times 4. Or times 2, I should say. So our rate of change is multiplying by 2 each time. It's a constant rate. So the last page I have to scroll down to show you all of them. If you want to pause and try this on your own, please do so. I'm going to keep going and give the answers here. This first table shows a quadratic relationship, because in this one, the rate of change changes by 1 every time. It increases by 1 every time. The rate of change does. We have an absolute value table over here. If you notice our rate of change, we are going down by 2. Then there's no rate of change. And then we go up by 2. I'm sorry. I should say we're going up by 2 each time. And then it changes back. So we have absolute value table there. This one right here, this is exponential. This one over here, this is linear. This one over here is also linear. And finally, we have a quadratic. And when you describe these, just describe the rate of change, whether it's constant, whether the rate of change itself is multiplying by the same number, etc. Look at all the previous descriptions. This concludes the video that we had. You now have homework you can work on. Again, any questions, bring them to class with you on Friday. I will be absent on Thursday as well. So bring these with you on Friday.